In this video, we'll look at an example to see how we put together load cases and load combinations, and also how we do this in LARSA. So let's look at this truss structure with a dead load of 10 kips applied at joints 2, 3, and 4, and live load of 13 kips applied at joint 2, 3, and 4. And we want to look at the following two load combinations, which we saw in the last video from ASC 7. These are just examples. So 1.4 times dead load and 1.2 times dead load plus 1.6 times live load. So we go to LARSA now. We've already created the model. You've done this now, so I'm not going through the creating the model part. But let's create a load case. We'll create a load case, rename it as dead load, create another load case, rename it as live load, and then create the joint loads there. So we'll go to the dead load and create the 10 kip load in the Z direction in joints 2, 3, and 4. And the same way we'll create 13 kips in the Z direction in joints 2, 3, and 4 for the live load case. So now we can make load combinations. We can just drag and drop the load cases into the load combinations. So load combination 1 has only the dead load, so we just drag and drop dead load into it. And then load combination 2 has both dead load and live load, so we drag and drop both of those load cases in. And then we can right click and open this matrix called the loading matrix, in which we can put the load factors. So for load combination 1, the load factor for dead load case is 1.4, and then 1.2 and 1.6 for load combination 2. So we can now save the model and run the analysis. So if we look at result spreadsheets and member forces, we can, for example, look at what is the largest force that occurs in member number 1, for example. If you look at load combination 1, there is a tension of 31.5 kips in member number 1. And if we look at load combination 2, there is a tension of 73 kips. So the load combination that produces the greatest force in member number 1 is load combination 2, and the largest force is 73 kips. And we can do this member by member to determine what the largest force effect on each member is.